Now I am taking up the 13th chapter, Similarity, of your first term course. And in similarity is somewhat similar to congruency, but still it is different from it. Actually, in congruency, you study about the congruency between the two triangles, and in congruency, the sides as well as the angles are equal to each other. Sides of one triangle are equal to the sides of another triangle, and angles of the first triangle are equal to the angles of the second triangle. Means they are equal in all respect. They are same in all respect regarding shape and size. If two figures are having the same shape and size, we say that the figures are congruent to each other. And we study about the congruency of triangles. The two triangles are said to be congruent when the sides of one triangle as well as the angles of one triangle are equal to the sides and angles of another triangle. The sides decides of the two triangles, the sides decides about the size. So if sides are equal, size becomes the same. And the angles decides about the shape. If the angles of both the triangles are equal to each other, then the two triangles will have the same shape. But in the case of similarity, the two triangles will have the same shape, but the size of the two triangles will be different from each other, but they will be in fixed proportion. Then only the shape can be the same. Now suppose if I draw two triangles like this is one triangle and this is another triangle. You see somewhat the shape are the same, but the sizes are of both the triangles are different. So we can say the triangles are similar, but the triangles are not congruent. So there is a difference between congruency and similarity. Now in this class you are going to study about the similarity of triangles. Now you know the symbol for congruency is this. Now the symbol of equality shows you that the sides of one triangle are equal to the sides of another triangle. And this symbol above the equality tells you that the angles of one triangle are equal to the angles of another triangle. So this was the symbol which you used for the congruency. Now as we are studying about similarity, and in similarity the sides of one triangle are not equal to the sides of another triangle, so this equality symbol you will not use. You will use only this symbol which shows the angles of one triangle are equal to the angles of another triangle. Now if I take two triangles and if I write this triangle as ABC and the other triangle as DEF, and if I write that angle B is equal to angle F, angle B is equal to angle F, if it is given or if we can show One pair of angles I have shown equal, and other pair, if I say that angle A is equal to angle E, this angle A is equal to angle E, then what do you say about the third angle C of triangle ABC and third angle D of triangle DEF? They will automatically become equal because the sum of all the three angles of the triangle has to be 180 degree. And suppose this is 30. If A is 30 degree, then E will also be 30 degree. And if I say B is 70 degree, then F will also be 70 degree. So what do you say about the third angle C? It will come out to be 80. And what about this also? It will also come out to be 80 degree because sum of the all the three angles have to be 180 degree. So I mean to say that you have to only show two pairs of angles equal to each other of the two triangles. You don't have to show the third angle equal. So if you show two angles of one triangle equal to two angles of another triangle, then the triangles become similar by the axiom AA. For congruency, we use the word property, but for similarity, we are going to use the word axiom. So how will I write? I will write triangle ABC is similar. This is the symbol as I told you. Similar to triangle. You cannot write, if you have written ABC for the first triangle, you cannot write DEF for the second triangle. You have to take up the alphabet or the letter which is equal to, that letter will be written first, which is equal to angle A. As A is written first, so which angle is equal to angle A? It is E. So write E first. And which angle is equal to angle B? F. So write F afterwards. And then D. So you should not write similar to DEF. How will you write? As I have explained you, write the letter, that letter, as E signifies the angles. So A is equal to E. So that is why E is to be written first. Because if you are going to write the letters of second triangle in proper form, then it will be easy for you to write the sides which are in proportion. So after writing this, as I told you, the triangles do not have the equal sides. These two triangles will not be equal in size, but they are equal in shape because angles decide the shape. But the sides will be in some fixed proportion. And how will you form the proportionality among the sides? You are going to take AB will be in proportion to EF. So that is why I am telling you to write the letters for the second triangle in a proper manner. So AB will be in proportion to EF. What will be the second proportionality? BC. BC will be in the same proportion with FD. And what will be the third proportionality? AC. AC will be in the same proportion with ED. So if you are going to write the letters for the triangles in a proper manner, this is how you are going to write the sides which are in proportionality. That is, the proportional between the sides AB and EF will be the same between BC and FT, and the same between, that is why I have used equality in between. Now you have seen that in all the proportionals, I have written the sides of triangle ABC in the numerator. It is not that you want to write for, in one you write for triangle ABC as AB, and here you do it the reverse, that you write FD first and BC afterwards. If you are writing the sides of triangle ABC as numerator, it should be the sides of the triangle ABC only in the numerator. And you see, sides of triangle EFD I have written in the denominator. So they are similar. When you show them similar, you have to write it as A axiom. As for congruency, you write the property. And you know the properties of congruency. What are the different properties of congruency? You must be familiar with all. One is SSS. These are the properties I am writing for congruency, not similarity. SSS. Then you have SAS. Then you have ASA, AAS, and RHS. These are the 5 properties for the congruency of triangles. And you see, in each property, you have at least one S. At least. Because if you show one side of triangle equal to the side or one of the sides of one triangle equal to one of the sides of the second triangle, then the triangles become congruent. Even similar triangles will become congruent. If you show one of the sides of one triangle equal to one of the sides of the second triangle, equal, not proportional. If you show them equal, even then the similar triangles become congruent. Otherwise, congruent triangles are always similar, but similar triangles are not congruent. So what is the first axiom which I have used? That is AA axiom. So that is why you do not have any property as AAA for congruency. You do not have any property. One side has to be proved equal to make the triangles congruent. Now I am taking the second axiom. For that, let me draw the figure. Now the second axiom which I will use is SAS. In SAS, I will show two sides of one triangle in the same proportion with two sides of another triangle. And the included angle as AUC is included between two S. And the included angle I have to show them equal. As I'm doing it with one example. Suppose this is triangle ABC and it is PQR, and I write that angle A is equal to angle Q. Suppose it is given that angle A and angle Q are equal to each other. And if I write for AB, suppose AB is 2 centimeter and PQ suppose is 1 centimeter. And I am writing for AC, I am writing 6 centimeter. And for QR, I am writing 3 centimeter. So now we are going to take these two S. You see two sides of triangle ABC are, lengths of the two sides of triangle ABC are given and lengths of the two sides of triangle PQR are given. Now suppose we will divide AB by PQ to find their proportionality. How much will be AB upon PQ? 2 upon 1. That is 2. And what will be the ratio of the sides AC and QR? AC I have written as 6 centimeter. QR I have written as 3. 6 upon 3 also comes out to be 2. Now you see that the two sides AB and PQ are giving you the proportion 2. And AC upon QR is also 2. So it means the two pairs of sides are in same proportion. That is, now I can write that AB upon PQ is equal to, or AC upon QR is equal to AB upon PQ, which shows that the two sides of triangle ABC are in same proportion. Two sides of triangle ABC are in same proportion with two sides of triangle PQR, and the included angle I have given equal. Angle A is included between 2 and 6 and angle Q is included between 1 and 3. That I have given equal. Now the two triangles ABC and PQR become similar by SAS axiom. Now I am going to take up the third axiom. There are three axioms to prove the two triangles similar. AA I have taken, SAS I have taken. Now I am taking the third one, SSS. For that also I am going to draw the figure for you. This is triangle ABC and this is triangle suppose PQR. And if I write AB is 1 centimeter, PQ is 2 centimeter, BC is 4 centimeter, QR is 8 centimeter, and suppose AC is 2 centimeter and PR is 4 centimeter. Now you form the ratio between the sides. How much will be AB upon PQ? It will be 1 upon 2. How much is BC upon QR? It will be 4 upon 8. That is also 1 upon 2. How much will be the ratio between AC and PR? That will be 2 upon 4. That also comes out to be 1 upon 2. So AB upon PQ is 1 upon 2. BC upon PQR is also 1 upon 2. AC upon PR is also 1 upon 2. This shows that the three sides of triangle ABC are in same proportion with the three sides of triangle PQR. So that is why you have AB upon PQ. Now it becomes AB upon PQ is equal to BC upon QR is equal to AC upon PR. So the two triangles become similar, and as I told you, this is the symbol for similarity. The two triangles become similar by SSS axiom. So I have explained today all the three axioms of similarity, and I have given you the difference between similarity and congruency also. Now in the next video, I am going to take up our exercise 13.1. So by that time, you watch this video.